this is the just general review for the final. Couple of administration things. Finals start Tuesday 8 a.m. Once Tuesday happens, pretty much I'm going to be in finals mode, which means all I'm going to be interested in is just proctoring finals. On Monday, 10 to noon and 1 to 3, if you have questions about grades, if you have questions about just the numbers of the your final grade, you can drop by then. I unfortunately will be unavailable for just general physics assistance because I got to make sure all the grades are in. If you have disputes or questions about grades for the lab, I'll pretty much try to answer everything except for the question, will I curve and what can I do extra to get an A or B or whatever. Grades only on Monday. The filing cabinets room, it's going to be open from 9 to 5. Come by then and get whatever you need or want, because once the finals are given, you're not allowed back into the building until January, and then I'm throwing everything away but the final once grades are out. So once I submit the grades for the final, everything gets thrown away except for the final itself. So if you want to dispute grades for the midterm, hold on to a copy of it and then talk about it in January. If you want, after Monday, if you still have questions about grades or you want me to take a look at anything, email only. So if you want me to look at a problem to see if I'm going to add on any points, send me a copy of it by email. I will not respond. I've got about 100 emails I'm going to go through over the weekend, and then I'll answer a few on Monday, and then after that I'm just shutting everything down except for grading finals and determining final grades. So pretty much once you take your final, don't go back into Lewis Hall until January 11th, because I'll be watching a lot of football in Fort Lauderdale. As for the final itself, it's not written yet. I don't write it until the weekend. I take my final seriously. That's why basically I'm going to go home here in Oxford and just sit in my office and ponder deeply what's going to go on the final. Overall, 6 15-point questions, 2 5-point questions, and then 50 2-point multiple choice. So that's just the general overview for the final. As for what specifically is going to be on the final, there's some things that I know for certain will be on the final. 1, vector addition. Eschenberg students know how to add vectors. Eschenberg students know how to convert vectors. As for whether or not it's going to be an appetizer or a full-on problem, I'm leaning on full-on problem, but it may be an appetizer. If it's an appetizer, it'll be primarily half the length of a typical vector addition problem. So this could be problem or appetizer, but it's 100% going to be on this test. 2D motion, it will be on the test. Now, granted, this is an oversimplification. The fact that you know that 2D motion is going to be on the test doesn't mean you know specifically what problem. Collision, inelastic. If I go with inelastic collision only, it's going to be an appetizer. Add energy. It will be more like an energy problem. Or I'm sorry, it'll be more like a 15-point problem. So if I just simply say you've got 2 kilogram mass at 5 meters per second, hits a 3 kilogram mass at negative 4 meters per second, and I say when they stick, what's the final velocity? That's going to be more like an appetizer problem, because that's simply momentum initial equals momentum final, m1 v1 plus m2 v2 is equal to m1 plus m2 vf. If I start asking things like energy lost, energy remains, becomes hybrid-like, and by hybrid-like it means climb a hill, hit spring, crosses frictional surface, does that weird thing with the arm that we've covered before. If I start adding things like this, if I start adding those weird things, and it becomes more like a pure, like a problem from the problem set for test 2 material. This is now worth 15 points. So it becomes a full-on problem. Rotation alpha is equaling 0. That's gonna be a problem. It's either gonna be similar to Fisher-Fury. Most likely it won't be named Fisher-Fury, it'll be called something else. Or it will be conservation of angular momentum. Now really what I mean by alpha equals 0, I mean there are no external forces acting, or torques acting upon this object. So it'll be like it'll be something like that merry-go-round problem, you know, where the kids start at the edge and they move toward the middle, and then you get the new rotation. Stuff like this. So it'll fall into one of those two categories. Atwood's machine, you're definitely going to get it with the get a Atwood's machine problem. It'll be either energy or motion. So know how to do those Atwood's machines specifically. Yes. Conservation of L, or angular momentum. For the Atwood's machine, if you're looking at the motion, look at test 1 review. If you're looking at energy, look at the T2 review. Both have been done in detail. The one thing that I will stress for the final algebraic manipulation. So for the Atwood's machine, regardless of it being motion or energy, you should be able to, like, V final, M1, M2, mu sub k, the length that the hanging mass starts over. I could put it on, well, lower priority. G, the gravity that you use, maybe it's on a different planet. Stuff like this. For the stuff like Atwood's machine, if motion, pay attention to that test 1 problem for the Atwood's machine with extra external force. With the energy problems, we haven't really done stuff like that, so I'm going to stay away from it. But if we do a motion of an Atwood's machine, I may do an external force on it. So pay attention to that first problem. One of the things that I will do over it's a bad habit that I do, but if I write my students an email, typically they write 2 or 3 back. Then the word gets out that I'm answering email, and then I end up with 500 emails in my inbox. Sometimes the rate at which the emails come in is faster than I can get them out. So if I don't respond to your emails, it's because I'm dealing with writing the final. I'm going to try to get, pretty much solutions of all the tests are either out there, or all I got to do is make a copy of everything, answering before the question comes out. I've been bitterly trying to get the multiple choice solutions done. However, let me show you how I can summon students to come and visit me. I literally take the page of multiple choice questions, pick it up, start reading, someone walks into my office. Literally 30, 40 people came to my office yesterday. I was unable to get it done. That's why I'm gonna kind of ignore email over the weekend, because I need to get those solutions out to help you. If I help one person, I hurt the class. It's a very weird idea. I don't like it personally, but it does work. I have to ignore the individual to help everyone. So I'm going to be working on solutions of the individual tests while the main test is written. That hybrid problem, it could be honestly anything. It could be that this problem was done Thursday a.m. Also, I've pretty much am ignoring posting, let me finish the question, posting the videos to the Google Drive. What's really easy is to just throw it up on YouTube, and then it's available to everyone really fast, and you don't have to download the whole thing, and that's just the easiest way. So just search for my name, and you can, and 213 final, and you can find it. As for the appetizers, I mean, really they could be anything, but I'm leaning towards test 3 material. And that could be anything: sound, Doppler shifts, fluids. The final covers, well, really 14 weeks of class. And we only have 3 hours to do the final. So what I'm going to try to do is I'm going to try to hit all the subjects, but I can't hit them all for the problems. So I fill them in occasionally with the multiple choice. So overall, everything is going to be covered in the grand design of the final. But I'm not, I can't be particular about guaranteeing, really, other than these 5. And even then, I'm being kind of vague. These are way oversimplified stuff. But I will promise you that
The problems have been covered in a lecture. I am not like, there are professors who say, well, if it's in the book, I can test it. I fundamentally disagree with that statement. I think it's lazy. I think that if I was to do that, what's the point of me standing in front of the class? So when you look at these things, I've covered them in class. That bucket problem with the flow rate of water coming out at a certain depth was explicitly covered in class. It was. So if you look at all the lecture notes, you've written all the problems down. I would look at the problem sets. Some people say that I don't have solution sets for the problem sets. I call them tutorials. In the tutorial, on every single week, I've done effectively 80 to 90% of all the problems, to the point where all you had to do was get a calculator and just crank it through. So for those problem sets, pay attention to the tutorials. And if I was to rank these, the number one would be the review sessions for test and final. So pay attention to those lectures the week of the test. Pay attention to this particular review session and the lectures on Tuesday and Thursday. Really what I'm doing is it's kind of a test bed for potential finals problems. Take a look at, as an example, the PM Thursday lecture. We were doing, and this is kind of required, moment of inertia, with parallel axis theorem. Now, one of the things that I tried to do was try to get an object with kind of a complex array of multiple objects. Failed miserably. However, what we did come up with that did kind of work is you have a stick. The length of this stick is 10 meters, and let's say that that distance was 7 meters and the rotation point was there. And I wanted to know what that distance is, what this distance is, and then I wanted to, the total moment of inertia is the moment of inertia of a stick plus md squared. The stick is 1/12 ml squared, and then md squared is this. So, and what we covered in this second class was, and this worked, this really worked a whole lot better, is I asked, well, if that's the center of mass, what's that distance right there? 5. What's this distance there? 3. What number will I put in that L? 10. Actually, I'm reading it from your, okay, thank you for flipping it around. That's 10. What's the value that you put in for D? For what? 3, yes. Because 3 is the, actually, use 2. This is 3 meters. D is in fact that distance right there. So if you know that distance is 3 meters and that distance is 7, and that is at 5, that distance has to be 2 meters. And so it's just simply looking at this picture and being able to do some basic reasoning. And so that's an example of, for something like this, I can see this either being an appetizer or a few multiple choice, where it's like what I try to end up, what the multiple choice currently is just a random pick from 175 multiple choice. And you've seen most of those multiple choice. Really, there's a part of me that thinks, you know, I could probably skip doing the solution set for the multiple choice for the finals because you have the solution sets for each of the tests. Put them together, what do you have? About 175 different multiple choice. So if I don't come through, like, look at T1, T2, T3 multiple choice solution sets, because they all flow in to the finals multiple choice pool. One of the complaints that the students have talked about is the fact that the multiple choice is random, as in it picks out 50 of the 175, and occasionally you get a set of multiple choice where 40 of the 50 come from test 1 material. I mean, it could happen. It's statistically possible. And what I'm going to try to do is take the 50 and divide it up to 10 to 15 test 1, test 2, test 3 multiple choice, like divide it into sections and then have a new section for new multiple choice. Now some of you go, well, the new multiple choice, trust me, after you've read 175 of my multiple choice, you'll be pretty prepared for the new ones that I throw at you. It's one of the things where, once again, I have another disagreement with other professors. They do the mastering physics, they do sapling, they do all these problems because they don't write problems for themselves, and then they write new problems for the test. And what happens is that there gets to be a disconnect in the wording between the problem sets that you do and prepare for effectively in the final or the tests. And for mine, think of the problem sets as rough drafts for the final. So if you're ready, if you can crank through all those problems, you're going to be ready for the final. And so for the person in the hat right there, you're blocking Pop because he moves, and then you move, and then you move again. I'm just trying to look out for my man. Now, let's see. Stressing algebraic manipulation. Anti-plug and chug. I've heard stories that there is a chemistry professor out there who stresses plug and chug. I think that's totally weak. If you understand the ideas behind the problems, I can give you any variant when it comes respect to the numbers. Understand problem solving. One of the things I thought about, I got to do, like every year I either sing a song, say something stupid online, or I don't know. But one of the things that I thought about, oh, and it just slipped my mind. Problem solving. I don't understand. I forgot. It was probably the cure to cancer, and I forgot it. Problem solving. It was about problem solving. It'll come back to me. Oh, numbers. I'm not going to write about numbers on YouTube over the weekend, but when it comes to numbers, there are, in my estimation, there are 3 big categories of numbers. And those are numbers given that you need. You're going to be given numbers, obviously, in a test where you're going to have to go, oh, I'm going to have to use that number, plug it in, and everything's fine. Then there are numbers not given that you don't need. Now, this is like the 6th or 7th year that I've been writing finals. When the first year, pretty much with every test, there was something wrong with one of the problems. I mean, there's always something wrong with one of the multiple choice, but with one of the problems, there was something fundamentally wrong. Now, after 5, 6, 7 years, there's one problem per semester that has a problem. We've already had it with the test 3 Atwood string problem with one of the versions. So I kind of take great pride of making sure that these numbers will work. In the situation where I do these weird mass ratios, where I go M1 is equal to 3M2, and I do not give you M1 or M2. And some people ask, well, you didn't give us the mass. And I say, what should be on my tombstone, it was a correctly constructed problem. That means you don't need the mass. Something is going to substitute out where it just drops away. In the third category are numbers given that you don't need. There will be an occasion, I don't know for sure, certainly on the test, it depends on how much time I have to write this, that I'll give you a number, let's say 4, and I see you desperately trying to take the number 4 and just pound it into the problem no matter what. It may be that I give you the number just to see that it's a dead end and you should know better and just avoid it. Perfect example, if you have a box sliding across the floor, coefficient of kinetic friction is 0.2, coefficient of static friction is 0.6. In these energy and motion problems, do you use 0.2 or 0.6? Do you use static or kinetic? Kinetic. So in the kinetic situations, you don't use the static numbers. In the static numbers, or in the static problems, you do not use kinetic numbers. And be able to know the difference. Let's see. What else? Don't panic. The final is 2 times a test in size. But in reality, you have the final is 2.4 times the test in time. So granted, it is twice as big, but you have an extra dose of time, and that's for review. The track record of a lot of these finals are that the normal students finish between 2 hours and 10 minutes and 2 hours and 30 minutes, roughly twice as long as the test. Granted, there are the people who would be there for 8 hours if given the choice. But by the time we get to the 3-hour limit, I believe roughly 2/3 of the class will be done. So the test is written for, it could be done between 2 and 2.5 hours with a half hour of extra time. Trying to think what else. Pay attention to the tests, pay attention to the review sessions, pay attention to the tutorials. If you can go backwards and forwards through all my lecture notes, you're effectively done. Just remember, I'm a big believer in don't complain to me after I've taught you A plus B equals C, and on the final I give you A and C and ask for B. You should have that problem-solving ability by now. I think in terms of just the overview of the final, I prefer the classes where, I prefer teaching classes Tuesday, Thursday, because it's easier for you guys to go from an hour 15 to a 3-hour final. There's a big difference between these Monday, Wednesday, Friday classes where they go from a 50-minute test to a 3-hour final, and they just get crushed. Hour 15, it's a little bit of a stamina run. It's a little bit more of a marathon than a sprint. Take your time, focus on each individual problem. Since I'm writing it at home, I'll be alone for 2-3 days. The test should be fine. So now we can talk about problems, whatever you guys want to do. Or just sit here. Yes?
On the Atwoods, if you ask for it in motion, and you don't give us velocity, we're still solid like it's velocity?
If I give you motion, probably if it's... If it's motion, most likely, what I'll likely ask for are acceleration and time. If it's energy, it'll be velocity. The main advantage of the energy problems is that you can get velocity almost, not instantly, but really easily. With motion, it's more acceleration and time. For each of these, be ready to solve for M1, M2, mu sub k, stuff like that. It may be for the energy, I give you velocity and I ask for one of the masses. In motion, I could give you an acceleration and then ask for something else. But a low priority, I would have to be in a really foul mood to do an energy problem and then ask for acceleration, or to do a motion problem and ask for velocity. I'd probably keep it straightforward. If I was only to give one problem on a test, then we could explore the space and do all sorts of bizarre permutations. With 50 multiple choice, 6 problems and 2 appetizers, gotta keep moving, keep that schedule going. So that's kind of it. Next question. Yes.
For the problem where it's like water flowing down the hill
Mm-hmm.
and needs to place in continuity.
Yeah.
So how come when you're given the velocity in meters per second and the radius are given in centimeters, you do it
I don't bother to change the units. Okay. In the case of equation of continuity, okay, my N's and U's look alike, a lot alike. You can never go wrong with using meters, seconds, and kilograms. I will always, unless I explicitly say you must provide an answer in a particular unit, I will always accept answers that are in forms of meters, kilograms, and seconds. So why do I use centimeters for that equation of continuity? Well, equation of continuity is A1 V1 equals A2 V2. So V2 is A1 V1 over A2. And let me rearrange this just a slight bit. If V1 is in meters per second, A1 and A2 could be in all sorts of whatever units you need. But units of A1 and A2 must match. If A1 is in centimeters squared and A2 is in centimeters squared, much like we did in some of the problems, those would cancel, and you're left with meters per second.
Okay, that makes sense.
Yeah, you can convert the centimeter squared to meter squared, but it's a time killer. It just chews up time, and it's an unnecessary part. It's more important that the units for A1 and A2 match. They don't have to be meters squared. So that's the point about that. Yes?
Can we do a good example of the hybrid problem?
Of the hybrid problem? I would say the one that's already done is take a look at the lecture from Thursday AM, and it's the last problem in the lecture. So I would look at around about 50 minutes.
That's the static.
Yeah, that's the static one. What did I do? I mean, that's the biggest one that I tend to do. The collision could be considered in an elastic, or the collision could be considered a hybrid. Let's go back to that. Okay. So in the example, a 2 kilogram object at 5 meters per second hits a 3 kilogram object at 4 meters per second. What's the final velocity? You have m1 v1 plus m2 v2 is equal to m1 plus m2 vf. So vf is m1 v1 plus m2 v2 over m1 plus m2. m1 is 2, v1 is 5, m2 is 3, v2 is negative 4. If I say 5 meters per second to the left, I mean negative 5 meters per second. Remember that velocity is not speed. It could be positive or negative. In this case, I was just being easy. This could also be 4 meters per second left. Oh, and I remember something else that I want to talk about. M1, 2, M2 is 3, So that's 10 minus 12, negative 2, divided by 5 is negative 0.4 meters per second. So this thing is going 0.4 meters per second to the left. And let's say it's now, so it's traveling to the left and it hits a spring, frictionless surface, so it's only hitting the spring. And the compression distance is 0.2 meters. What's the spring constant? So for something like this, you're dealing with the energy initial is equal to the energy final. Energy initial is the kinetic energy initially. Final is the potential energy. Kinetic energy, 1/2 m1 plus m2 v squared. Potential energy is 1/2 kx squared. I'm looking for k, solve for k. Halves cancel. m1 plus m2 v squared, v squared divided by x squared is equal to k. m1 is 2 plus 3, 0.4. The negative doesn't have to go in there, but it doesn't matter because it's squared. X squared is 0.2 squared. And so now I have to finally use the calculator. 5 times 0.4 squared divided by 0.2 squared. Oh wow, 20 newtons per meter. So hybrid merely means multiple regions of information that are used within the same problem. What did I do in this problem? I did conservation of momentum because there was an inelastic collision, and I did conservation of energy because an object hit the spring. So stuff like this. These type of problems look at the second group of problem sets, i.e. test 2 problem sets for collisions, and you get a good idea of what these could be. So problem set, how many problem sets do we have for test 1? 5. So I would look at 6, 7, and 8. Most likely, I think 6 and 7. Probably 6. One of the things that I was reminded just now is there's going to be graphical references in the multiple choice. So we were talking earlier about the multiple choice and how it's random, as in you could end up with 40 multiple choice coming from test 1 material. One of the things that I've been thinking about is blocking them up. And one thing may be 5 multiple choice pulled from 10, covering those waves, which has 2 antinodes, which is the 3rd harmonic, which is the 4th overtone, stuff like that. Another section would be, there would be an inclined plane problem or an Atwood's machine problem. And I would go which one's mg sine theta, which one's mg cosine theta, which one's mg, which one's the normal force, stuff like that. So there will be a graphic and you will refer to it. Trying to think, there was another one that I really liked. I don't know, maybe something new. I haven't figured it out. This, because it's what I'm looking at. And this is one of the things that I do. There's a student, I won't give you their name, but I privately tutor them. I can't tutor anybody in 213, but I can tutor people in 211. And there's a student in particular that I've been tutoring the whole semester, and it gives me an opportunity to just rant and rave about how much I dislike other professors and what they do, because they're not like me. One of the things that this particular professor said in their review session is they don't believe in covering material from the lab on the final. And I'm like, well, that cuts out so much fun stuff. And one of the things that it will be a section, it may not be the section that you get, it's just something to think about, is the motion 1D pre-lab. I covered it, and it's the day that I basically danced around the front of Brevard Hall, walked in different ways, and you would have like stuff like this. And as a sample question, if A is acceleration, well, it wouldn't be A, because if it was this, it'd be more like this or this. But if something is acceleration, which plot is velocity? Remember that pre-lab. Remember that lecture. There will be a section, potentially, of questions that come from just that. And so these would be the big three graphics that I could be referring to. Yes? Yes. I believe it was test 1 where we did this. So I would go back to test 1. I would go back to the lecture that I did for this, and I would look at the pre-lab for that particular lab. I think it was number 2. I think it was lab 2. So it was fairly early in the semester. So it's one of the things that I'm building towards. I may never get to it. It's just a destination that I aspire to reach, is eventually have my test completely standardized and multiple choice, so that I don't have to spend 4 days grading this thing. I can just slam it through the Scantron and have it done in half an hour. And sections like this are stuff that I'm playing with. And if you were to look at the don't bother. I would look at the finals that I gave you, summer 16, spring 16, fall 15, summer 15, and that's as far back as I would go. There's a natural evolution to this, that if you got a hold of a physics, and they are out there, a physics 211 final from the fall of, no, it would be the spring of 2011. If you can find one of those and just I've got a copy. If you look at it, you're like, this is nothing like what he does now. Completely different sections, completely different style of problems. It's kind of normalized to a typical set of problems, but there's a natural evolution. Stuff older than 2 years is probably outdated. I wouldn't bother with it. I would stick with the big 3 that I posted on Blackboard. Those would be the ones that I'd do. I'd take a look at. Is fall 15? I think fall 15. A test of fall 15 was up. I'd have to really dig around and find a fall 15 final. I'm not sure I want to go looking for it, because then it would just give me ideas as to put on the test. So I'd rather avoid it. If I do the multiple choice for the 3 finals that I posted online, I'm done. I'm not going to do anymore. The rest is just overkill. I started doing multiple choice 2 years ago. With every test, I would write 10 to 15 multiple choice. This semester, I was writing 2 to 3. The final, I'll probably write a lot more, because I want to do sections like this as well. But when you look at those, you're going to go, that's like his old stuff. I just have to reword it to make it look like this. Next. Yes.
What about that Atwoods with the torque that you said was going to be on the final with the string that went up the wall and then?
Oh, well, that's. It's less of an Atwood string problem. That's the hybrid problem that I did Thursday morning in detail. I wouldn't call it an Atwood's machine problem. I would call it a hybrid problem now. I may keep that in reserve, because this thing, it covers sound, it covers torque. If I've already done something like this and a sound problem, star becomes unnecessary. It all depends on my choice of problems. Let me. I'll give you an analogy of how I think of writing problems for a final. When I write problems for a final, probably this evening I'll write an outline. Saturday I'll write problems and do some solutions, and I won't do simply 6 problems and 2 appetizers. I'll write like 15, 20 problems. And it's a lot like starting a garden. And after a couple of weeks, there are a couple mutant plants that didn't really grow all that well, plants that you look at and go, I don't even know what this is going to be. And so what you do is you weed them out, and you get the stronger plants, the plants that are more solid. On Sunday, I'll make the cut. I'll go from 15 problems down to 6 and 2 appetizers. And those will be the ones that I'll type up and include in the final. So there will be problems like that mutant one that I spent 15 minutes on Thursday afternoon with the moment of inertia off center for the stick, and it got all complex, and it just went bad. And it's a lot like a little plant that it just grows up all mutant. And you just have to make a decision and say, look, dude, you're off. You're dead. And just throw it away. And then that's why I simplified it and wrote that other one that I talked about earlier. Will that one be on the final? I don't know. It depends on how much room I have. And a lot of times I'll write a test, and then the next day I go, what idiot wrote this? This is going to take 5 hours. And so then what I typically do is on the second day, I trim it way back. So that honestly, if I can't do the 8 problems and 2 appetizers in 20 minutes, I don't expect you guys to do it in 3 hours. So I'll just run right through it and double check everything. The numbers will work. The numbers will be clean. The numbers will be nice. I think the Atwood string problem from test 3 was a one-of. It was just a one-shot mistake. I'm eternally paranoid now about mucking it up. Because honestly, what happened, and it's just something that I'll consider for final grades, because one of the versions was messed up, the students who had that version got all screwed up in the head, and that propagated into the other problems. Then the people with the right versions, the versions that worked, they were wondering about the other version, and they were panicking too. So it's one of the things that I try to do is I take my finals seriously, and I want to maintain a level of serenity amongst the students and make sure they get through this all right. I don't like having students just freak out in the middle of the final. So with tests, I kind of emotionally abuse you guys, but for the final, I understand what pressure you guys are going through, so I tend to be neutral, but it'll be fun. Just zen. So it'll be okay. Did that answer the question? I just go on rants. I don't know.
I mean, so it could be on there, but maybe not. That's really what I said.
Maybe. It'll be on there. It will not be on there. Maybe I'm lying. Maybe I'm not. Maybe I'm lying about lying. It'll be, it all depends. It depends on my mood. It may, and I don't know. I think the tests, I gotta go through the motions. The finals, I gotta make a statement. What does that mean? I don't know. It's the culmination of an entire semester. For a lot of you, you'll never see the inside of a physics building again. And so it's the last time for me to make sure you know what you're doing. For the 214s, it's just a little parting gift before you come back in January. So, and now that they've left, we can talk about the answers on the final. So it's what's really on the final? Well, I've already written it. Let me put it up on the screen.
Let us hope you make one problem, just one of the 6.
Well, no, I'm not.
You thought about it.
You tempted me. I know, flick the camera off and then, I would pay, the big hint, well, a lot, I think the final is going to look a lot like, be thankful we no longer do it, so that's why I make the final look like it. We used to do lab finals. I know, right? It would have been awesome. And the lab final was basically an hour-long written test, which was basically 5-6 quizzes spliced together. And then you moved into the next room. You may notice right now that the 221 lab room, they've got the windows covered. And that's because on those 12 tables, they pick 4 labs at random, and they set up 3 lab stations, and when they assign you a random number, you walk into the room, you sit down, you perform an hour-long lab experiment, and then you turn that in for a grade. So there's gonna be portions of these labs that are in the final. Atwood's machine, you've done Atwood's machine. That's going to be on, that was in the lab, that's going to be in the final. Vector addition, you did that in lab, you're going to do that in the final. Know your units. And just so I alleviate the fears, the average for my particular labs was like an 84 to an 85, which is kind of good, but not, it's still below. The average that I want to get for the labs is an 87 to 88. So that about 45% of the labs get A's, 45% get B's and are thankful for it. And then there's a few C's and D's who are basically like, well, I didn't show up for lab. I mean, you really have to stink up the joint to get a C. Basically, what have I been saying? Go to lab. If you don't go to lab, you don't get a B or an A. Even though everybody has very low morale in BB's and John Rock's labs, they're going to see curves. They're going to see big curves. I'm not above curving the final. If the average for, now, don't everybody tank the final and expect me to curve up. But if the average for the final is 100 out of 200, we'll curve up. It's fine. I need you guys to demonstrate. I want you guys to demonstrate that you've learned something over the course of a semester. That's why it's comprehensive and covers everything. Question. Someone. Average for the final is generally lower. Oh, I know. The average for the tests have been high. I've said it in other classes and I'll say it here. If I think that the average for the class is running high, I say the class is running hot, which means I gotta cool this thing down. They're high, but it's not obscenely high. There's a high proportion of honors and provost students, and I'm not above giving a higher proportion of A's because of that. There was an instance of a summer section, they lowballed me. They basically said, oh, we're so dumb, we don't understand, please make the test easy. 20% of the class got over 100. 80% of the class got a 90 or above. They were high-fiving each other in the classroom. And I stood there and I was like, okay, fine, have your day, well done, well done. And I nuked them on the second test. Nuked them right back into submission. And the averages worked out. Don't think I'm being frivolous about the final. I put in thought about the final. With the tests, I admit it, test one from this semester was test one from the fall of last year. Exactly. I just changed the dates and shipped it. I put in a little more effort for test 2 and test 3. The final, which is 30% of the grade for your final grade, I take seriously. Real seriously. It'll be fair, it'll be thorough, and it'll be okay. All right, any other things? We're all slowly heading towards the door, I can see it. I would just look at all the videos. With a combination of Google Drive, YouTube, and your notes, you've got it all. All right, the motion is on the floor to adjourn for the semester. Going once, going twice, sold. See you next Tuesday and Wednesday.